Welcome to this model. In this model, I gonna speak about temperature measurements. Any material placed above absolute zero temperature emits electromagnetic radiation from its surface. So both amplitude and frequency of the emitted radiation depends on the temperature of the object. The cooler the object, the lower the frequency of the emitted electromagnetic waves and lesser the power emitted. The temperature of the object can be determined from the power emitted. Infrared thermometers measures the magnitude of the infrared power in a broad spectral range, typically from 4 to 14 micrometers. Actually, temperature is one of the indicator of the general well-being. Two types of temperature measurements can be obtained from the body, and the two types are systematic temperature and the surface temperature. Systematic temperature is the temperature of the internal region of the body. Usually the heat is generated by the active tissues of the body and heat is lost by the body to the environment. But the temperature of the body is maintained carefully. And the normal mouth temperature is 37 degrees Celsius and the normal underarm temperature is about 36 degrees Celsius, that is 1 degree Celsius lower than the mouth temperature. And systematic temperature is measured accurately at tympanic membrane of the ear. The brain controls the temperature, that is it has temperature control over the body. And usually Mercury thermometer will be used to measure the systematic temperature. It is inexpensive too, but when continuous temperature recording is necessary, this Mercury thermometer cannot be used. In that case, we can use thermocouple or thermistor. In thermocouple, a junction of two dissimilar metals produces an output voltage, and this is proportional to the temperature at that junction. The thermocouple is a sensor used to measure temperature. Thermocouples consist of two wire legs made of different metals. The wire legs are welded together at one end, creating a junction, and this junction is where the temperature is measured. When the junction experiences a change in temperature, a voltage is created. The voltage can then be interpreted using thermocouple and to calculate the temperature. There are many types of thermocouples, each with its own unique characteristics in terms of temperature, range, durability, vibration resistance, chemical resistance, and application compatibility. And the thermocouples are used in many industrial, scientific, and OEM applications. And there are many types of thermocouples. And its temperature range may be, if type K thermocouple is used, its temperature range is 454 to 2300 Fahrenheit. Whereas its extension wire has a temperature of 32 to 392 Fahrenheit. And its accuracy is plus or minus 2. If we use type J thermocouple, and then its temperature ranges from minus 346 to 1400 Fahrenheit. And the temperature thermocouple may be of grounded thermocouple, ungrounded thermocouple, and exposed thermocouples. In grounded thermocouple, this is the most common used style. A thermocouple is grounded when both thermocouple wires and sheath are welded together to form one junction at the probe. And grounded thermocouples have a very good response time because the thermocouple is making direct contact with the sheath, allowing heat to transfer easily. A drawback of the grounded thermocouple is that the thermocouple is more susceptible to electrical interference. Then the other measurement can be made by using thermistor. So thermistor is the word derived from thermal resistor. These are the type of semiconductor, meaning that they have greater resistance than conducting material but lower resistance than insulating material. The relation between the thermistor temperature and its resistance is highly dependent upon the material from which it is composed. The manufacturer typically determines this property with a high degree of accuracy, and thermistors are made up of metallic oxides, binders, and stabilizers thrust into wafers, then cut into chip size and left in disc form or made in another shape. There are many shapes available for thermistor. The precise ratio of the composite materials governs the resistance temperature curve. And thermistor derived from the term thermally sensitive resistors are a very accurate and cost-effective sensors for measuring the temperature. And thermistors are available in two types, the negative temperature coefficient and the positive temperature coefficient. Negative temperature coefficient thermistors resistance decreases as the temperature increases, while PTC, that is positive temperature coefficient thermistors, resistance increases as the temperature increases. So only NTC thermistors are commonly used in temperature measurement. And the thermistors are available with a variety of base resistance and resistance versus temperature curves. Thermistors are often selected for applications where ruggedness and reliability and stability are very important. They are well suited for use in environments with extreme conditions or when electronic noise is present. They are available in a variety of shapes. The relation between the resistance change and temperature is usually non-linear. And the resistance of the thermistor is given by the expression RT is equal to RR into e power beta into 1 by T1 minus 1 by T0. RT is the resistance at temperature TT, RR is the resistance at temperature T0, and T1 is the temperature at which the measurement is taken, and T0 is the reference temperature, and beta B is the temperature coefficient. And special circuits are used to overcome the nonlinear characteristics of the thermistor, and these special circuits will consist of two matched thermistors. And the major disadvantage of using thermistors are self-heating. That is, self-heating is an important problem. It can be overcome by limiting the current used in the measurement. The power dissipation of thermistor is to be maintained in milliwatts to overcome this problem. The thermistors are available in several common configurations. The three most configurations are the hermetically sealed flexible thermistor, the bolt washer type, and self-adhesive surface mount type. Thermistors are highly accurate but only over a limited temperature range, that is within about 50 degrees Celsius of a base temperature. The working temperature range for more thermistors is between 0 degrees Celsius to 100 degrees Celsius. Class A thermistors offer the greatest accuracy, while Class B thermistors can be used in scenarios where there is less need for exact measurement. Once the manufacturing process is complete, the thermistors are chemically stable and their accuracy doesn't change significantly with age. And the second category is skin temperature measurement. Skin temperature is not constant throughout the body because it is varied from 30 to 35 degrees Celsius. Various factors may affect the skin temperature, and you can see which are the now let us see what are the factors that affect the skin temperature. It depends on how fat covers over the capillary area, and how the skin portion is exposed to ambient temperature, and how the blood circulation pattern is there beneath the skin. Here also the skin temperature can be measured by using thermistor probe, but it should be chosen correctly based on the resistance range and sensitivity. If we use a probe for measurement, a small flat thermistor probe is used for measuring the skin temperature. And infrared thermometer can also be used to measure the skin temperature. Infrared thermometer is a device which is used to locate the cancers and by identifying the temperature variations. This infrared temperature thermometers have significant advantage over both glass and thermistor thermometer, and they eliminate reliance on conduction and instead measure the body's natural radiation. They use ideal measurement site, the tympanic membrane of the ear, which is the function of the core body temperature. And this infrared radiation can be used as a detector. So the detector used for measuring the emitted infrared radiations are thermopiles, pyroelectric sensors, Gauge cells, photoconductive cells, and photovoltaic cells. So all these devices can be mounted in a specially designed housing to measure the surface temperature without direct contact with the body. So handheld infrared scanners are now available for monitoring the pattern of the skin temperature changes, particularly for tympanic membrane temperature measurement. This measurement is based on the development of new type of sensor called pyroelectric sensor. So a pyroelectric sensor develops an electric charge that is a function of its temperature gradient. The sensor contains a crystalline flake which is pre-processed to orient its polarized crystals. Temperature variations from infrared light striking the crystal changes the crystalline orientation, resulting in development of an electric charge. So the charge creates a current which can be accurately measured and related to the temperature of the membrane. Thank you.